Alright, so as a reminder, okay, so your midterm examination will be in between 7 to 30th September 2020. Alright, so chapter that we cover for the midterm is chapter 1 up to chapter 4. Okay, alright, so we proceed with our lesson. Okay, so we're already in chapter 6. Okay, so kita pun berada di minggu ke-6. Right, so chapter 6, momentum and impulse, very simple. So we suppose we can complete within 2 hours, but maybe less than this pun boleh because very simple je lah. Right, so this one I think you already seen this one, the learning outcome. Right, so I will simply proceed to the definition for the momentum. Right, so the definition for the momentum, basically we take from the equation of the momentum. Okay, so because the equation, we form the equation from the definition. So we can define the terms, okay, based on the equation. Alright, so no problem. It's defined as the product between mass and velocity. So that is momentum, which is vector quantity, and this is the equation. Okay, product between mass and velocity. Okay, so we have apa? I have introduced this term, which is momentum. Okay, in chapter 4. Okay, force. For when we apa panggil principle of Newton second law tu. Okay, so kita ada kaitkan dengan momentum. So from there, you have seen this word. Okay, maksudnya tak bukan yang baru untuk awak lah. Cuma yang ni, we're going to focus totally on the momentum. So what is momentum? Momentum is product between mass and velocity. And the unit, we take the unit for the mass is kilogram, and the unit for the velocity is meter per second. Alright, so must always be meter per second because this is the SI unit. Cannot be kilometer per hour, yeah. Alright, the direction of the momentum is the same as the direction of the velocity because for this case, mass is scalar, and the only that vector is velocity. So your momentum will follow the direction apa of the velocity. Okay, and then momentum. Okay, so sama. Bila dia vector, then we can resolve dia pada dia punya komponen. So tak kisahlah berapa komponen yang dia ada. Kenapa? Kejap ibu kelas. Kejap lah. Kejap ya. Kejap. Hai. Kejap dia tak kacau. Okay, so same lah. Kalau dia once dia adalah vector, then we need to consider the direction. So where the direction can be whether component X or component Y. Alright, so let's say if we have this vector, okay, this momentum, right, direct in this direction with an angle here, right, then we can resolve it to the X component and to the Y component, where we can get it as for the X component is mv cos theta and Y mv sin theta. Also possible to have Z component. Mana tak keluar? Oh nanti kejap lagi kot. Okay, but for your level, we only consider sampai YX component saja, 2 dimension saja. Okay, momentum into dimension saja. Alright, and then let's see impulse. What is impulse? Okay, so let a single constant force act on an object in a short time interval. Alright, thus Newton's second law can be written as, okay, so here we relate with the Newton second law, where here the impulse actually is the change of the momentum, or the difference of the momentum between final and the initial momentum. If there's no change, then that's mean the impulse equal to zero lah. Okay, so this case for apa we have impulse when we have difference between before and after the apa momentum. Okay, and then here we have force uh, or else, okay, we can write it as force times time. Okay, change of time. So that from here we can see that it equal to the value of the change of a momentum. Okay, so the unit, okay, so the unit must be Newton second lah. Alright, because tadi kita ambil F times dengan masa. Alright, so the unit akan jadi Newton second. Or if you want to write it in this way pun boleh juga, kilogram meter per betul ke? Kilogram meter per second jadi macam unit momentum. Unit momentum. Okay, betul, unit momentum. Okay, because the impulse is change of the momentum. Okay, so unit dia samalah macam unit momentum. Alright, if the force acts on the object is not constant, then what happen? We have F, average. Okay, then kita akan ada average and positive force. So then it often easiest to use them in component. So the impulse in this one for case on the force acts on the object is not constant, then we may find the impulse by using the integration of force dt. Okay, but this one tak cover lah in your syllabus sebab kita your syllabus only consider algebraic punya situation je ataupun solution. So we solve only using algebraic punya cara lah. So we never have this case lah. Alright. Okay, so as I mentioned before, so it can be in any component x, y, and z, but we only consider collision which only cover the 2 dimension. Alright, so we will ignore the z lah, only x, y sajalah. Alright, when two objects in collision, the impulsive force against time. Okay, let's say we have this. This is the plot for the force against time for a collision. So maximum force occurs here. So the force increase and maximum occurs here, and then after the maximum force, that force will decrease by the time. Okay, then what happened? So we can have the area under graph as the impulse. Okay, as the impulse. So that's only the things that you need to know in chapter 6. Ni salah chapter 6 In chapter 6. So very simple. So we have only here berapa question kat sini. So you learn about momentum. So momentum is just equal to mv. Okay. So momentum basically kalau keluar memang akan jadi soalan bonus for you. But I'm not sure why. From my experience, okay, student tend to to leave this question. I don't know why. Okay, sepatutnya you score this question. Okay, sebabnya you score this part. Sebabnya momentum very simple, but it's just dia look quite complicated since you have pecahan-pecahan macam ni lah. Kalau keluar pasal-pasal yang glancing ni, ada komponen X, komponen Y, maybe it seems like complicated, but the fact is if you try to solve, you can answer it, dapat jawab lah biasanya. Susah lah macam tak nak kata tak dapat jawab tu. Okay, cuma tak tahu kenapa tak ramai student yang favor this question. Okay, macam dia tak boleh nampak apa itu impulse, what is momentum, dia macam tak dapat nak bayangkan. They still cannot imagine what is momentum. Okay, even they just can describe that momentum is the product of mass and velocity, but what is momentum? Macam tu. So suppose you just need to use apa yang ada je lah. Tengok macam example kita pun simple je. Okay, so here we have an example. Alright, so 0.2 kilogram tennis ball strikes the wall horizontally with a speed of 100 meter per second. Bounce off with a speed of 70 meter per second in opposite direction. Calculate the magnitude of impulse delivered to the ball by the wall. Okay, so again, so what is impulse? Impulse, simply we take it as change of the momentum. So you just simply need to find the momentum for the first at first dia nak strike the wall ni, and then after strike the wall is your punya final momentum. Then you just simply need to minus that two momentum and you might get your impulse. Biasanya simple macam tu je, but careful if it have two dimension punya case. Okay, if that case is two dimension punya case, careful. Okay, you cannot simply minus like this. You need to consider the X component, Y component. Okay, macam for this case, kebetulan memang one dimension saja, X component saja. So, X component lah. So, only one dimension that we need to consider. If not, then you need to consider both X and Y component, and then macam biasa, masuk balik dekat dia punya equation yang untuk cari the magnitude, and then masuk balik dekat equation yang cari untuk cari direction. So, biasa student miss tang tu lah. Biasa dia terus ambil, dia tolak macam ni. And forget to layan yang y-axis tu. Okay, so cannot be like that lah, because you will lost marks kat situ. Alright, so we get a negative impulse. Since the question asks you the magnitude only, then you give the magnitude lah, 34 Newton second. B, you need to find the time. The time pula. You need to find the F average. Okay, so here the value for the force is when you substitute the time here and substitute the magnitude. It's up to you whether you want to substitute the minus sign or not. Okay, but if just question just asks to find the magnitude, then you may ignore your negative sign. Okay, then you may get your force is equal to 3400. Next example, we're going to see example where the information is on a plotted graph. Okay, so quite challenging juga macam ni sebab you need to remember this is force. Nampak ada kilo, kena consider kilo. Nampak ada millisecond. Alright, so need to careful lah kalau dapat soalan macam ni. 60 gram need to convert to kilogram. That one you need to always remember. Why? Because kita guna ada unit Newton kat sini. So tak match nanti. Kalau kilogram tak boleh masuk dalam unit Newton. Must change to kilogram, then baru dia boleh masuk dalam Newton tu. The impulse delivered to the ball. So find the initial impulse. Impulse just now is the change of the momentum. But for this case, how we're going to find? Simply take the area under the graph. Okay, so we simply take the area under the graph and we may find that the impulse value is 14.4 Newton second. Alright. And then you need to find the speed of the ball after being struck. Assuming the ball is being served, so it is nearly at rest initially. So at initial point, at rest, so we just need to find the final velocity, right? So impulse settle. Okay, so masukkan balik dekat equation change of momentum, then simply you get your punya final velocity. So kalau memang one dimension, soalan momentum ni memang boleh jadi soalan bonus lah untuk awak. Macam tu lah saya boleh cakap. Okay. Sebab dia punya konsep tu very simple. It's just mv and then impulse is change of momentum, or you have equation for force times time. So very simple. So we have exercise. Okay. And then simple je lecture kita hari ni. Lagi satu kita ada conservation of momentum. Right? So we have learned about Alhamdulillah. We have learned about conservation of linear momentum and impulse. Janganlah. Okay. Alright, so this is your learning outcome. Okay. So the principle is principle of conservation of linear momentum. Alright, so before this we have learned about conservation of energy. Okay, but we learn about today we're going to learn about principle of conservation of linear momentum. So what's the condition ataupun dia punya syarat to allow you to use this principle of conservation of linear momentum? Then we're going to see this. Okay, so when the net external force on a system is zero, the total momentum of that system is constant. Net external force on a system, ya, on a system, bukannya on macam mana, bukannya pada satu benda saja. Macam mana saya nak cakap? Okay. So basically macam dia akan involve dua objek yang ada velocity lah. Maksudnya yang bergerak. Maksudnya jaranglah kita guna prinsip of conservation of linear momentum ni untuk kes yang macam langgar dinding macam tu. Faham tak? Maksudnya dia kena external force on the system is zero. The total momentum of the system is constant. Maksudnya it's about collision. Okay, akan berlaku collision yang ada impact lah. Okay. Alright, so it means that net force equal to zero. Okay, so from Newton's second law, okay, so the change of momentum equal to zero. So we get the change of the momentum equal to zero. Okay, so dia tak sama macam tadi kita belajar ada impulse kan. So impulse is change of momentum. Okay, but for this case kita consider satu system. So satu system tu the net force equal to zero, then the change of momentum akan equal to zero. Therefore, your momentum akan constant, which is maksudnya your before and after, okay, your total of initial momentum, okay, akan always equal to total of final momentum. But depends ya, tak semua case, alright. Macam yang tadi kita ada kan, kalau dia ada change, maksudnya momentum dia tak sama, then dia akan ada impulse. But yang ni lebih kepada net momentum, right? So we can write it also in this form. So we have two types of collision, which is elastic collision and inelastic collision. It is defined as one in which the total kinetic energy as well as total momentum of the system is the same before and after collision. Okay, so this one elastic. So rasanya awak pun dah biasa yang ni. Okay, cuma I think for this level penambahan dia adalah dia boleh jadi collision yang 2 dimension. So maksudnya before ni mungkin awak dah belajar elastic but maybe on 1 dimension je kot. Okay, so now in for this in asasi level, okay, so we are going to see what happen when we have bila collision, after the collision tu, okay, so that ball berlaku glancing ataupun akan menyebabkan dia ada angle macam tu. So kita itu je lah kot penambahan dia. Okay, so cuma yang ni elastic, the case for elastic, what happen before collision, you're going to have different velocity and which after, where after collision, okay, the direction of the collide object tu, okay, akan will have different value of velocity with different direction. Okay, the properties of elastic collision are the coefficient of restitution equal to 1, but this one is just only the properties je lah. You don't need to know how to calculate yang ni. Okay, alright. The total momentum is conserved. Okay, the total kinetic energy is conserved. Okay, so means that for elastic, to solve the elastic collision problem, we can use these two principles. Okay, so if you want to find the velocity, initial curve, final curve, then you can apply these two equation, right? Because from or we can expand the kinetic energy, then we get this. So this part is for initial, this part for final kinetic energy. What happened in elastic collision? Okay, so in elastic collision, one in which the total kinetic energy of the system is not the same before and after the collision. So means that the only equation that can be used is only the conservation of momentum. Okay, so tak boleh guna conservation of kinetic energy for case in elastic collision. Kalau guna pun awak akan rasa benda tu tak logik. Why? Because it's going to have same value of velocity at the end tu. Okay, so itu adalah untuk syarat berlakunya in elastic collision. Where after collision, whether it stick or together or not, but it have same velocity, then that case dah consider masuk dalam, we classify it as in elastic collision. It's not a must untuk dia stick together. Okay, it can also sometimes dia follow je with same velocity juga. Okay, same direction, same velocity. I mean after the collision tu lah. So nak nemas lah untuk dia stick together. Alright. So what's the properties? The coefficient of restitution is between 0 and 1. The total momentum is conserved. Total momentum. And total energy is not conserved. So this not allow you to use the conservation of kinetic energy punya equation. But you still can use total energy. Faham tak? Okay, so total kinetic energy tak boleh, tapi total energy masih may apply. You may still may apply for this case. Macam yang elastic tadi, dia boleh apply yang Ki equal to Kf. Okay. But for this case, your K final akan plus dengan losses energy, whether it is sound or heat, semualah dia akan bertukar jadi that energy, the kinetic tu. So that's why the velocity dah tak sama lah macam tu. Alright, so linear momentum in one dimension collision. Let's see the example. Let's say we have two different mass object. Okay. collision occurs head on. Head on collides. Head on means that elastic collision. Alright, so they have different initial velocity. Right? Okay, semua at this part, you need to write all the initial punya part. So MA, MB, tulis saja macam ni. Kalau dia kosong pun tulis je equation yang macam ni, then later on baru you masukkan value. Then from here you may get your velocity for A after collision to the left together with the sign, means that if negative then means that that ball move to the left. Let's say we have this case. We have two-dimension collision. So how are we going to solve this kind of problem? Alright, so let's say we have before collision, only one dimension that involved. Okay, sebab dia kata apa? One dimension, dia kata suppose 20 meter per second, 4 meter per second, okay? Alright. And then after collision, your V1 make 50-degree angle. Okay, calculate the magnitude and direction of soccer ball after the collision. Okay. Let's see how we're going to solve this kind of problem. So at first, again, we simply apply the principle of conservation of linear momentum. Okay. And then but this time you need to separate X and Y. So we have component X. So you write your initial and final for component X. Then here 0. So apa? Sebab this static at first. Then there's 0. And then after that you have at last 2 you have cos theta 1, because we don't know where dia pergi kan. Okay. And then when we simplify, then we may find the velocity of X. And then from the Y component, we can find the velocity of Y. Okay. From there, the magnitude of the soccer ball kita akan masukkan dalam equation yang ini. So inilah maksud saya yang agak complicated sikit untuk momentum. But since it is vector, just simply treat dia sebagai vector saja. So tak ada masalah. Cari komponen X, cari komponen Y, then masukkan balik dalam equation your magnitude and find your tangent V2Y minus V2X, and you may find the direction. Okay. Again, please don't just leave it like that. Please explain where the angle to. Alright. So dah masuk exercise, then finish. Okay. Alright. Habis. Okay, cuma kita tengok satu example yang hari tu kita tak tengok habis, sebab saya kata kita KIV bila kita dah masuk dekat apa panggil tu chapter ni. Okay, so kita akan sambung sikit yang tu. Diamlah. Okay, so kita tengok salah satu example yang apply boost. Okay, dia apply kinetic energy principle of conservation of energy, and okay, this example. Alright, and the conservation of momentum. Alright, so let's say for this case, okay, so we have a static block waiting here and a bullet masuk dia. Okay, so bullet tembak, then akan stop lah. Then automatic dia akan move together lah. Alright, so 5 gram, remember to change to kilogram, 5.5 centimeter, remember to change to meter. Alright, so this is the case. So bullet embeds in the block and together swing through a height 5.5 centimeter. Calculate the initial speed of the bullet. So to calculate the initial speed of the bullet, at first we need to okay, so let's see the case dulu sebelum nak terjah nak pakai apa conservation of energy ke conservation of momentum. Kita tengok nanti kat mana yang momentumnya, kat mana yang conservation of energy yang kita boleh guna. So let's start with this dulu. Okay, so apply the principle conservation of energy involving the situation 2 and 3. So 2 and 3. So let's see kita ada apa. Yeah, here at this point. Kenapa tak keluar? Oh, at this point we have kinetic energy, which maximum kinetic energy. Okay, sebabnya dia terus bergerak. Tapi dia punya panggil apa? Dia punya H is 0. Okay. And then dia apa? After a while dia move up H with a value of H yang mana given 5.5 centimeter tu. Okay, so we have that is your potential energy. Okay, so kita consider maximum lah. Dia naik tu sampai tahap maksimum macam tu. So we can equate these two energy. Alright. So here from here we can get the value for the U12. Okay, tapi dia nak soalan nak velocity here kan. Now we only have the value for velocity for both. Okay, yang move together. Kalau awak tengok pun tak logik lah kan. This as the bullet punya velocity. So how we can find the value for this velocity at this point? Then we can use the principle of conservation of linear momentum. Okay, so from here we substitute the value that we have and you may find your bullet punya velocity. Barulah logik. Then the question asks you to find the energy loss to the surrounding. Okay, so you can simply minus. Okay, sebab tadi E2 and E2 sama ya.
Madam dah gerakkan slide ke?
Dah, kenapa?
Dia macam tersekat dekat slide yang tadi tu.
Oh, tapi yang ni nampak saya soalan ni.
There's last piece dekat example 5.10.
Oh, ya ke? Kejap. Nak student ibu. Ni, dia jalan tak? Keluar tak? Sekejap, saya tak ada internet ke? Janganlah adik.
Yang ni nampak?
Okay, boleh Oh, tadi dia tak gerak
Tak gerak.
Oh ya ke, maksudnya saya kena ulang balik ke? Okay. Okay. Alright, so sorry Ni tak nampak Okay. Ni nampak dah Kejap lah. Okay, so at first again, okay, so let me explain again. Kenapa tak boleh guna highlighter? Oh, boleh. Okay, so we have kenapa tak boleh guna highlighter? Okay, faham. Alright, so for this case, for second and third yang akan conserve. Okay, yang akan conserve. Okay, sebab dia dah consider satu sistem. Maksudnya dia dah consider both mass tu. Okay, yang ni kita tak boleh consider lah lagi sebagai dia energy to conserve sebab dia that object tu pisah. So yang ni dia dah stick together. So then apa yang kat sini akan sama dah dengan yang kat sini. So that's why yang akan conserve. Okay, so again macam saya cakap, kalau kita nak consider dia conservation of energy tu, dia kena close system. Maksudnya tak boleh lah sini kurang mass, sini tambah mass. So memang akan ada energy loss lah kat situ. So we cannot consider lah yang ni. That's why kita tak consider at this part equal to this energy. Faham kan? Alright.
Madam,
Ya.
Madam still tunjuk page 50.
Oh ya ke? Alamak, saya kena stop sharing dulu ke? Saya rasa sebab ni kot dia nak complete validation. Okay, mungkin sebab ni. Dah kah?
Tak ada slide, madam.
Ya ke?
Ada slide.
Oh, saya pernah present. Sibuk tadi. Dah Sekejap, saya cuba.
Dah.
Ni nampak dah?
Nampak?
Okay. Sorry, saya tak perasan ingatkan nampak dah semua. Okay, saya ulang balik Alright, so we try, okay, so from this case, we try to classify it into the case so that easier for us to solve that this problem. Okay, so at first, this is the case. So this static, and then the bullet and the velocity. And then second case, dia dah embed together. And then third case, at the last situation, what happened is dia dah embed and then dia make a height. Dia naik atas sikit. Okay. So, macam saya cakap tadi, okay, so we will apply principle of conservation of energy for case 2 and 3. Since because case 1 is not isolated punya system, dia bukan closed system. So that bullet tu masih tak masuk sini lagi. Maksudnya dia, so memang akan ada loss energy. So that's why kita tak boleh equatekan dia lah. So for case yang kita boleh equatekan adalah yang memang dah closed system, which is case 2 and 3 here. Okay, so kita bolehlah equatekan dia. So the principal energy, so where we can have maximum kinetic energy at here. Okay, so with this velocity, and then dia make a height, then means that sampai maximum, tahap yang maximum, so means that that is the maximum potential energy that they will have. Okay, so from here we're going to find the velocity for these two things move together. Okay, maksudnya bukannya velocity yang kita nak ni lagi. Okay. Kejap ada budak kacau ni. Adik tak mula bising. Diam. Kejap je. Okay, so from here, the velocity that we find here is not the velocity yang kita nak lagi. Sebabnya velocity, the question asks you to find the velocity of the bullet. And from here, we can see that the value pun tak logik lah. Kan? The value is 1 meter per second. Takkanlah bullet bergerak dengan that velocity. So, then from here, how we can use this information to find this velocity. We can use the conservation of momentum. So bila kita masuk dekat equation momentum, and this is case yang inelastic, then at last dia akan ada satu velocity, which is the velocity that we find from the conservation of energy just now, and we substitute into this equation. Okay, so initially tadi kan block tu at rest, so that's why kosong. So we only have the momentum for the bullet. Okay, so from here we may find the value for the bullet velocity is equal to 209 meter per second. And B, the question asks you to find the energy loss to the surrounding. Then we can give the difference between energy at 2 and energy at 1. Okay, so we can consider it apa different in the kinetic energy lah. Ni macam yang tadi lah. Macam yang tadi yang ada tunjuk kat question kejap yang tunjuk kat equation yang slide yang dekat chapter 6 tadi. Okay, yang dia kata K dia kata apa? K loss yang dia kata K final sama dengan K initial tambah energy loss tu. Dia panggil Q. Q loss. Okay. So that's why kita boleh ambil K final minus K initial. Okay, ataupun K initial minus K final. Then we can get the value of the energy loss is 109 joule. Okay. So that's one of the example yang combine for case yang combine the conservation of energy and the conservation of momentum. Alright, so since we have few minutes, okay, tak adalah few sangat, banyak masa lagi ni. Okay, so I want you to do this exercise. Okay, so buat exercise yang ni ya. Ada kat you future. Slide saya ni ada kat you future. So tolong buat exercise ini. Okay, sebab kan kalau kita ada sejam lagi. So gunakan sejam ni untuk buat to do this exercise and we're going to discuss this on the next class lah. Okay, tak payah submit tak apa. Cuma kalau ada yang tak reti jawab nanti kita discuss untuk masa next class. For next class, we're going to see rotational motion chapter 7. Okay. Even the midterm examination awak only cover sampai chapter 4, but please follow je ya. Chapter 6, buat juga ya tutorial macam biasa, tengok video macam biasa sebabnya memang kita kat sini belajar consistently. Okay, if not nanti takut awak tertinggal banyak. Okay, cumanya nanti yang penting nanti masa seminggu midterm tu berapa bulan 7 sampai 13 tu kita tak ada kelas dalam masa tu. Cumanya maksud saya sekarang adalah tutorial buat macam biasa. Maksudnya janganlah awak ignore pula. Awak kata okay ni tak masuk exam kan. So ignore. Jangan macam tu ya kelas. Okay, so please do it macam biasa jugalah. Okay. So I leave it to you with the exercise. So if you have problem doing this, we can discuss this on the next class. Boleh kelas. Tutorial, saya rasa tutorial tak banyak. So we can combine je lah dengan next tutorial. Tutorial 4 dan 5 kita combine sekali. Okay ya kelas? Boleh? Any question?
Boleh, madam.
Boleh. Any question?
Tak ada.
Dia semua kat rumah dah ke tu?
Tak.
Rumah.
Balik kampung ke?
Tak balik.
Oh, okay. Apalah ya, kafe buka macam biasa Sebabnya kita tak cuti pun kan. Senin pun kelas macam biasa, sekolah je cuti. Okay, I think that's all for today's class. Alright, so anything regarding our lesson then you may may ask me lah. Okay, apa-apa boleh kelas. So I hope that you already start to find your tajuk untuk your punya entrepreneur assignment tu juga. So saya harap awak dapat gerakkan sikit-sikit. Okay, TTN nanti tak adalah kalut sangat sebab saya pun akan check juga. So next week saya akan tengok problem statement. So I hope you prepare with that. Masa tutorial saya akan check. Okay, boleh? Alright, I think that's all for today's class. Thank you, class. Assalamualaikum. Take care.
Thank you, madam.
Thank you, madam.
And
You're
Thank you,
welcome.
madam.
Thank you, madam.
Welcome. Bye.
Thank you,
Bye.
madam.
Thank you,
Bye.
madam.
Thank you,
Bye.
madam. Thank you, madam.
Alright, bye. Have a nice day.
Thank you, madam.
Welcome. Bye.
Thank you, madam.
Welcome. Bye.
Madam,
Ya?
nak tanya boleh?
Mhm.
Ni bukanlah pasal visit, tapi ni pasal bantuan kewangan untuk S44.
Oh, okey. Ha.
Untuk saksi, sebab itu kita orang punya taklimat, dia cakap boleh minta mentor. Kalau macam madam kontrak dengan UiTM ke? Ataupun
Oh, saksi eh? Boleh je. Saya boleh je.
boleh. So boleh tak untuk S44 kalau yang kalau siapa yang tak dapat saksi tu kami minta madam, boleh tak?
Boleh je.
Boleh.
Awak ada ke yang tak lepas hari tu? Ada yang kena reject borangnya?
Kami belum hantar lagi madam. Kami baru taklimat minggu lepas.
Oh, ya ke?
Ah.
Saya ingatkan you dah dapat. Oh, belum.
Belum. Surat tawaran pun bulan depan insya-Allah dapat.
Oh, okey. Boleh je. Cuma
boleh,
hari ni saya tak adalah. Minggu depan
insya-Allah tak tahu minggu depan kot.
Minggu depan.
Okey, madam.
Okey, nanti bapa beritahulah bila nak tunya.
Okey, insya-Allah. Boleh je.
Okey.
Okey, thank you, madam.
Ada kot saya ada kot. Okey.
Okey, thank you, madam.
Alright,
Assalamualaikum.
welcome. Bye. Salam.